Welcome to the solution of ISI M.Math 2024 question based on linear algebra. We are basically discussing the subjective section. And so this is another question that has been asked in 2024. The question is saying that V be a finite dimensional real vector space, and suppose P1, P2 be two non-zero linear transformation from V to V such that the following conditions hold. What are the conditions? The condition is given to us that P1 plus P2, sum of these two linear transformation is the identity linear transformation. The second one is saying that P1, P2 equal to P2, P1, this is equal to 0 linear transformation. Now what I need to prove that the following statements holds. What is the first statement? Pi squared equal to Pi for I equal to 1. It means each of these linear transformation P1 and P2 are idempotent linear transformation. Okay, starting with the part A. So what I need to prove, Pi square, this is equal to Pi for all I equal to 1. Now let us start with the first given condition. P1 P2 is equal to identity. P1 plus P2, this is equal to the identity linear transformation. So I can write P1 composition P1 plus P2, this is equal to P1 composition the identity linear transformation, right? More precisely, I need to write a vector alpha, so I'm just, for the time being, I'm avoiding that one. Now, so what is the definition of this composition? That would be P1 P1 plus P1 P2. This is equal to P1 composition identity linear transformation, that gives you the P1. Now P1 P2 that is given to us is 0 linear transformation. That becomes P1 square is equal to P1. The same way one could prove P2 square is equal to P2, and I'm just leaving that part. So that all about our part A. Now let us move to the part B. Now what is this part B saying? Part B is saying that, just a minute, let me erase it. So part B is saying that what I need to prove, for each I the following statements are equivalent. It is the first statement. What is they are saying? V belongs to PIV. It means V, the vector V belongs to the image of Pi. Is, and the second statement is saying that Pi small v is equal to small v, right? So what I need to prove, what is the meaning of these two statements are equivalent? I mean this hold if and only this. So let us choose a vector, let V belongs to, in place of I am just using 1. For the 2, that would, the proof would be the similar. So P1 V. So by definition of image of a linear transformation, I can write V equal to P1 of U for some U belongs to capital V, right? For some U belongs to capital. Okay, so now we are just marking as a star equation. Now what is given to us? We already have proved this part. This part, Pi square is equal to Pi. I need to use it. So P1 square, this is equal to P1, right? So these two are mapping as same. Now let us find out the value P1 of square U, this is equal to P1 of U, right? So this will imply P1 of P1 U, this is equal to P1 U. Now let us use the value of P1 U. P1 U equal to V. So P1 V, this is equal to V, right? That's what I need to prove. P1 V is equal to V. So the necessary part is done, and I need to prove if P1 V equal to V, then V belongs to P1 image set of P1. This part is quite easy. If V equal to P1 V, by definition of image of a linear transformation, that belongs to PV. That's all about our part B. Now I need to prove the part C. So let me erase it. Just a minute. Okay. Now the third part, what is it saying? That zero vector is the only intersecting vector between the image set of P1 and image set of P2. Now for this, let us choose a point alpha belongs to P1 of V intersection P2 V, right? So therefore, alpha belongs to P1 V as well as alpha belongs to P2. Now observe that what I have proved, if alpha belongs to P1 V, then P1 of alpha, this is equal to alpha by using the condition V. So I can write P1 of alpha, this is equal to alpha, as well as alpha belongs to P2V implies P2 of alpha is equal to alpha. Now, in place of this alpha, I am just using P2 alpha. So P1 of P2 alpha, this is equal to alpha. So that becomes P1 P2 of alpha is equal to alpha. But interestingly, observe that by the condition is given to us is P1 P2 or P2 P1, both of them is equal to 0. So this becomes 0 is equal to alpha, as this is that is the zero linear transformation. So what I have becomes alpha becomes the zero vector. Therefore 0 is the only intersecting vector between P1 V, P2. This completes the proof. It was quite a easy question.